Okay, guys, thanks for joining. So today we're gonna discuss about a new topic. Basically, we will be going through the interface between ROS and the drones. Okay, so that is the topic. This is a new chapter. Uh, First of all, I'm not a very fan of drones, but I actually work with drones. So you may be thinking like, why you work with drones if you are not interested in it. So I have like a 6 months experience in this. I have looked for some internships while I was doing masters, and I got it in Carnegie Mellon University, US. And okay, okay. So I was saying about one of my opportunity in CMU where I work with drones. So I actually applied to CMU and I got it in a lab called Air Lab. Maybe I'm not sure you have heard about. So Air Lab actually working on drones. Okay, their main thing is drones. So in order to get internship, I actually contacted a person in Air Lab. Okay, and at that time in CMU, I think this lab only have the opportunity. They were looking for a ROS developer. So I was not very interested in drones, and most of the work are related to drone system level, creating system level applications, testing, then working on SLAM, all these kind of things. But in that time, I could learn about, I mean, somewhat something about drones and ROS. Okay, so we have used ROS one. It is happening in 2018, by the way. So this lab is actually, I mean, heavily working on drone research. Okay, mainly mapping, then navigation. Not only drones, I mean, aerial vehicles, aerial robots, basically. Okay, they all also a UAV. Yeah, yeah. So they actually created an autonomous helicopter. Maybe I can share this link so that you can also check. So there is a project. I forgot the name. Yeah, this one. You can see. Yeah, autonomous helicopter. ACUS autonomous helicopter. So this is like they created a software stack, and the helicopter will move autonomously. The helicopter will pass a mountain by avoiding the obstacle. So it's an interesting stuff. I think maybe we can check some videos. It's interesting. I have seen the code and all. Let me check if there is some videos. Yeah, autonomous aerial cargo. So the objective may be the autonomous cargo. Um, let me just play some videos for the same. Yeah. Um, yeah, you can see here there are some sensors on the front, maybe for mapping. This seems like some kind of planning. Yeah, you can see big sensors, mostly laser scanners. Yeah, this is, I think this is a professor. No, 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 this is not the professor. So they have deployed big sensors on the front, and this seems like some NVIDIA board. It seems some computer. It seems, and this is inside. I mean, in helicopter, the inside view actually. You can see the companies. Near Earth Autonomy is actually a company spin-off from CMU Air Lab. So you can also find Near Earth They are mainly working on again aerial vehicles, UAVs. So this is also a spin-off company from Airlab. I can share that. Yeah. So basically, you can find there are a lot of works actually happening in drones, but this is not my favorite domain. My favorite domain is in wheeled robots, then social robots, then legged robot. I mean, that is actually coming, but mainly wheeled robots. It's my favorite domain. Yeah, so I was talking about the air lab that I work with, and some of the experiences are like these guys are like um, very talented in mapping navigation, and they are also publishing a lot of paper in high-end conference like ICRA, IROS, and all. And they have some openings as well, like if you want to do internship, if you are in US, they have set of opening. But if you are passionate in drones, I think then only you will get it. They participate in the PA challenge, and you can also see the latest publications. You can see most of the publications are like most of the publications published in high-end conferences. Yeah, so that is one of my experience. This was a professor, Sebastian Scherer, and I have worked with Wen Chan. These guys are very experienced. They were doing postdoc at that time. Yeah, so yeah, this guy was there, and currently he's doing PhD. Yeah, the team is actually strong, quite strong. Okay. Okay, 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 okay. Fine, fine, fine. Yeah, yeah. So maybe I can discuss some topics that I personally know. Okay. But I don't know. Like we will discuss the avionics side, but let's see. Maybe if something is useful, then you can take it. Okay. Fine. So in this 6 months time, what I was mainly working was with a drone called DJI M2 210 or something. Yeah, 210. It's a very rugged drone. I'm not sure you have seen this. It's very expensive as well. Yeah, yeah. This is a drone. So basically, you can use this drone for like imaging. In order to inspect some bridges or like yeah, I mean complex scenarios, right? There are a lot of complex architecture buildings are there, so this is perfect for that because the range is very high. You can fly it with in a very big area. Okay, and it's very sturdy. Okay, so this was my first experience with the drone. So I'm just saying my experience, and after that we can start with the topic. So I think you can connect something from it. That's why I'm saying. Okay. So the objective of this project, like that I'm involved was, I can show you the projects. Cinemat cinema. Sorry for the typo. Maybe Google will correct it. Cinematographic drone, NVIDIA CMU. Let me check. This was a paper, I guess. I was not in the other. Yeah, this was a project that I have worked in. This actually appeared in NVIDIA blog because we have been using the NVIDIA TX2 and all. This was the paper. I was not in the author, I was mainly helping the PhD students to like creating the system level um, uh, applications. Okay, so mainly ROS related. So this was the um, paper. The title is Autonomous Drone Cinematographer. So the objective of the project was like currently the cinematographic shots. I mean, usually various shots are capturing in drones using drones, right? But uh, there should be a perfect, I mean, person to control. Okay, but in order to create this cinematographic shot autonomously, um, I mean, this project is about that, creating autonomous drone application mainly for the taking cinematographic shots. Okay, so during this project, the Skydio is also came. Skydio, I think you may have heard about the Skydio. It's very interesting drone, and we have bought this drone into the in the lab actually to test it, and the experience was awesome. But this project is, I mean, mostly related to Skydio. But I mean, we are planning for a like bigger level. I mean, there is no project because Skydio is a closed source project. There is no code open source. But I think this project, like we have published a paper, and I think code also like some code may be available as open source. Okay, so so that was the objective, and you can see some planners like we will drive the drone, and initially what we have done was like we have put a tracker on the head of the actor. This is actor. So based on the coordinate and all, the the tracker in the helmet and the drones are communicating, and there is a base station that is controlling by me. So all these are communicating, and the I mean, the drone know the GPS coordinate of the actor. Okay, and it's not normal GPS, it's RTK GPS. I'm not sure you have heard about RTK. It's very real-time kinematics, I think that is the full form. It's actually very expensive GPS, and it need another antenna, and the accuracy will be very high. Okay, so we have used the RTK GPS, and yeah, and if there is any obstacle, occlusion, the planner will be avoiding that. You can see here. Yeah, so these were the main aspect of this project. So the project actually implemented in the DJI drone, that is M210. Okay, and yeah, mainly these guys are actually the contributors, and this was my first experience. So I can talk about something like maybe I can start with DJI drones, and then we can get into some other topics. So DJI, if you I think it's very familiar to you, the DJI drones. We are seeing these drones for like parties, like in order to take the aerial shots. We may be seeing this drone. This is very popular. You can see this in marriages and all. Okay, and there are mini drones which can be used for photography, personal photography, and so there are different ranges actually. So mini, then this kind of drones, and there are some professional drones as well. So that's where the these series like Metris 300, 210, all these series are coming. So all these drones are built using carbon fiber. Okay, it's very strong. Even if it is fall down, I don't think it will break easily. But what they did was they actually created some joints like if you check this joint now, sorry, this joint, when it hit the floor, this joint will easily, I mean, um, uh, uh, it's not breaking. Somehow it is like, I mean, um, what it is actually disassembling from the drone. I don't know, like this joint is actually, we can easily remove it. Okay, so if the entire system is very rugged or like very fixed, then if it is, if the drone actually falls down, then the impact is very high, right? But if these wings are like removed when it fall down, I think the entire impact can be reduced. I mean, there are some logic in this. So it's a very rugged drone with a lot of cameras, and also you can add the additional camera. There is a gimbal, and you can control it. And so how we can control it using ROS or from our PC? That is a question. Okay, so these drones are, I mean, we can use it without programming using the joystick. You can connect to some tablet, and you can see the view of the camera and the map, everything you can see. But if you want to use this drone for development, then there is an SDK. Okay, there is an SDK. So that is an interesting part of it. So if you are using a DJI drone, there is a thing called DJI SDK. Okay, DJI SDK, and there is also DJI SDK ROS. Okay, so you got an idea, right? So if you want to work with the DJI drones, you don't need to, I mean, create a new framework or something. It's already there. Okay, so in DJI drones, there is a serial port connectivity. It's not, yeah, it's a serial port connectivity. Yes. Okay, so from the drone, you will take these cables, serial, I think it's RS-232, yeah, RS-232, and you can connect to your PC. Okay, so it's like RS-232 USB converter or something, and you can plug it into your computer. Okay, so then you can simply communicate to this drone like an Arduino. Okay, you work with the Arduino serial communication, right? So like that, you can easily control these drones. Yeah, I mean, yeah. So these RS-232 USB, I mean, converter, or this connection can able to control the entire aspect of the drone by sending commands to it. Okay, so if you just plug these USB into your computer, okay, for example, you connected a Raspberry Pi into this drone, okay, and you connected this USB into the Raspberry Pi, okay, and then if you have a Wi-Fi connection from Raspberry Pi to your computer, what you can do is just log into Raspberry Pi and then send commands from Raspberry Pi to the drone. So the drone will obey it. So just like the teleoperation, we can control it from the PC using a C++ or Python program. You can do like a takeoff, landing. Yeah, I mean, there is serial ROS library to communicate with Arduino and all. Arduino, but this is a different device. I mentioned it's like Arduino. It's not Arduino board. Like in no. It's not Arduino. It is having, this drone is having, for example, I can this drone having inbuilt computer inside it. Okay, and that inbuilt computer is doing all the balancing, then the camera integration, and I mean almost all the stuff. Maybe I can take the the drone I have worked with. Just a second. Yeah, this one. Let me take the image. Yeah, so you can see here these drones having the rotors, and it is having gimbal cameras. Then there are inbuilt cameras. This is the inbuilt camera, and there is a stereography camera, like left and right. You can see there is a stereographic camera, and on the bottom, left and right, you can see the batteries. Okay, and from the top portion or the back portion, you can able to take the serial cable. Okay, so this is having a powerful computer inside. Okay, all the balancing, all the takeoff, landing, all the things are doing by this controller. So what we are literally doing is that we are actually communicating to that controller. Okay, we are communicating to that controller. So like if you send a command like take off, if you send it from your Raspberry Pi, then the drone will be taking off. And if you give a command like land, then it will land, something like that. So we don't need to do any kind of complex programming. We can simply command it. Okay, that is what we are doing. We were doing in that project. So we have the DJI drone SDK, and I mean the SDK is available for multiple versions. Okay, and you can set it up on your NVIDIA TX2 or NVIDIA Nano, whatever the board you are using. Okay, and not only SDK, there is a ROS support as well. So the things are getting easier. Okay, so like you can so this is for ROS 1, I guess, mostly ROS 1. So what you have to do is you can take a Jetson Nano or Jetson whatever the NVIDIA boards are, because I am preferring NVIDIA because there is a camera images coming from the drone, but there is a catch in that. In order to get the camera images, there is another port. Okay, so using one port, we can control it. Using another port, you will get the camera images. Okay, I think there are two connection that we need to interact with the drone. One is for the control, and second is for the multimedia. I mean, not multimedia, like the images. Okay, so obviously, like in order to create a drone application, maybe imagine you are creating an autonomous drone application. Okay, like autonomous navigation. So for that, you may be using vision, you may be like using the point cloud, whatever it is. You need to process it, right? So if you are using a Raspberry Pi board, I don't think you can do all the things inside Raspberry Pi. If you are working with a simple application like taking off and rotating in circle, those kind of application doesn't require any processing, right? It is simply giving the goal position to the controller, and the controller will move, or the velocity commands to the controller. Okay, it will move. But in order to create autonomous navigation application or mapping application, there should be some onboard processing going. Okay, so in that case, what you have to do is you can connect the computer. What we have done was the drone having legs, right? So we created a 3D printed chassis which can be clamped into the legs. Okay, I think there were two TX2. Okay, one is doing the autonomous navigation and all, and second is doing simply the commanding or something. Okay, so we have clamped the TX2 here, and you may be thinking how to get the power. So the power, you can tap it from the battery itself. Okay, so on the back of this drone, let me just which one? No. That, I mean, it's actually like, maybe I can explain, just a second. Let me take. So, so we didn't do any kind of like, what like we have added the computer into the drone, right? So there is a payload for this drone. I think it's like, I don't know, 2-3 kg. So that kind of payload that we can add to the legs, there will not be any balancing problem with the drone. So like what we have done was, we have added those payload. Basically the payload here is the computer. Okay, so there is no, I mean, balancing issues. There is no need to check the center of gravity, because like, even if you put some weight, maybe on the tip or something, the robot or the drone can balance. It can handle. So that's why we chose this drone, because the payload was good and the balancing is also good. Okay, so the drone related things we didn't work on, like the balancing. We didn't care about the balancing, or I mean, we don't need to, because everything will be handled perfectly by the DJI drone. We only focus on into the application side, like how to take it off, how to take off the drone, land the drone, how to move the drone in a specific velocity, and yeah, those kind of stuff. Okay, so yeah, so we have basically used the DJI onboard SDK ROS driver. So the things are very easy. Like, we will start a launch file, and what happening is that the driver will be starting, the DJI drone driver will be starting, and then we can able to communicate with the driver using topics and services. Okay, so for example, if you want to take off the drone, just call a service. Okay, the drone will be taking off. And if you want to land, you can just call a service. And if you want to like move the drone in a specific speed, then you can send some topics. Okay, so like there is an option to set the waypoints, and also like we can give the command velocity, like the wheeled robots, we are actually sending the command velocity, right? So similar to that, we can able to command the drones using the command velocity. Okay, so this no, computer vision is entirely developed. Computers, those kind of things, the top level is completely built, because because the thing is that the DJI driver will only give the basic data from the drone. Like you will get the camera images, you will get the I mean, we can send the commands. So those kind of stuff is provided by this driver. Okay, rest of the stuff we have to do, like all the detection, then the navigation, all the things, that is the application part. Okay, that application is completely developed. Okay, so using this driver, we can able to get the images, and like we can able to control all the aspect of the drone. Okay, so I'm not showing the demo, because we can't able to set the drone, but you can able to just see like how the DJ. Yeah, yeah, I can show you that. I can show you that maybe after this topic. After this topic we are going to that. Yes. So you can check this driver, DJI SDK. We can able to um, command the drone. You can set the roll PTO value, and yeah, you can command. Yeah, all these things you can command from ROS topic. So that's why we are using the um, ROS driver. Okay, it was very easy to work with. So you don't need to worry about the other stuff. So from one topic we will get the images. You can see here we will get the stereo, then gimbal, images, everything we will get. Okay, so that is the flexibility that the DJI drone gives. It is very development friendly, and yeah. So I was just talking about my experience, how we developed the project that you are seeing here. It was not easy because for testing the robotic arm and wheeled robots, I mean, it's not very complicated. Like if you have some space, you can test it. But just check this diagram. I mean, just check these images. I can play this video. I don't think I will be there, but okay. This is actually the uh, uh, video that prepared for the paper presentation, I guess. So here, the drone is circling the car. Okay, the car is moving, and the drone is actually trying to circle around the actor. So when the actor actually moves, the orientation changes. The drone also changing its path. So you can see these all things are happening in RVs, and you can see the grids, right? Those are like obstacles. So the gimbal actually changed. This is the actor, the walking actor. So you can see here. I am somewhere here actually. Yeah. And the testing was very hectic because this area, now this area is like a desert, and in order to test the drone, we should have a very big space. Okay, and there will not be anyone in the um, I mean in the surroundings. Okay, because that can be, I mean, detect as an actor. Okay, or some kind of noise. So we have to test it in a very desert area, and testing drones are very difficult. Okay, so yeah, so these were the issues, and also the debugging was difficult because like if there is an error, we have to like I mean again land the drones, and we have to correct the code. Okay, so yeah, so this was the project, and uh, yes, so getting back to the main topic, just a second. So we have seen how the DJI drones, one of the famous drone company, though that is working. Like if we have a computer that we can put it in the drone, we have the onboard SDK ROS package, in which you can simply clone and start the driver, and you can control the drone. Okay. Okay. So that is one thing. Let me close all this stuff, and let me take our syllabus. So the syllabus actually talking about um, like Ardu Pilot, Pixhawk. So these are like designed for hobbyists. And I also plan for a simulation, but that actually takes some time, and some just showing like mapping, localization, all these things how we can do. So what I'm planning is like giving an overview of these things. Okay, so let's start with these some of the topics. Maybe I can start with a website called Drone Code. uh, yeah, before that I need to discuss something. Okay. Okay. So in this chapter we are planning to discuss how to interface your drone and ROS. Okay, that is the ultimate objective. And also, like, it's not about the actual hardware but also the simulation. Okay, and from my experience I will say for drone application the simulators are very important. Okay, because physical drone testing is very difficult. As I mentioned, like, in some universities there are some indoor environment for testing the drone. Okay, but all the drone application can't be done indoor, we have to take it out. So I was very, what I will say, it was very hectic job working with drones, because we have to take the drone outside. And even with in winter, like I worked from Jan to July. Okay, so you can imagine, and it's Pittsburgh. Pittsburgh is like, what I will say, it's like full of ice, full of snow. Okay, so even with ice, we don't have any choice. We have to take the drone out, okay, with gloves, and we have to test. Okay, and also, like, in summer as well, it is difficult because we have to again take the drone, and you have seen the location, right? So working with drones is not easy. What I'm trying to say is that the importance of simulator. Okay, even if we are working on the actual drones, before testing your code in the actual drones, obviously what we will do is testing in the simulator. Okay, testing in the simulator. So for wheeled robots, it is okay. Like, even if you don't have the simulator, maybe you can test it indoor, wheeled robot, if it is Turtlebot 3 or something. Okay, that is okay. But in case of drone, that is not the case. Okay, so I just want to show you some important simulators that we can use for testing the drones. Okay, so in my project as well, the main simulator that we have been using was AirSim by Microsoft. Okay, AirSim. Okay, it's actually a project built using Unreal Engine, and then they also looking for Unity 3D. So all these are game engines. I'm not sure you have heard about Unreal and Unity. Unity is very famous. I mean, both are famous. So the AirSim actually mainly created by guys from CMU. They joined in Microsoft and they created this simulator. And the purpose of the AirSim was there was mainly two purpose. One is simulating the drones, and one is simulating the cars. Okay, so cars are for autonomous self-driving application, and drones are also for the autonomous operation. So we can see a video, so then you will understand. So just check the difference between AirSim and Gazebo. Okay, so we are this is a view that we are getting from the simulator. Okay, just check the view. It's very realistic, right? It's like playing a new game, right? And not only the environment, but also you can check the data that is coming from the simulator. Okay, on the bottom side you can see there is a depth image, there is a segmented image, and there is a RGB image. Okay, so why it is important? Because most of the drone application, this is actually a parrot drone. I'm not sure you have seen the parrot drone. It was a very famous drone. I'm not sure they are currently building drones. um, I can show you the drone that is seeing. Yeah, this one. Okay, so this drone was very famous. Okay, that drone is actually showing on the simulator, and the drone on the front of the drone there is a camera, okay, and the camera, the simulator itself doing these kind of computation. Like it can give you the depth image, okay, it can give you the segmented image. Segmented image means like it is actually segmenting based on color, and yeah, so it is giving some like some AI based data as well, like classified data. So using this you can create lot of application. Okay, so this is one of the realistic simulator that we can use for drone application. Okay, and the good thing is that if you want to extend AirSim, it's an open source project. Okay, you can simply clone from it, and you can this is like the AirSim is actually an Unity, not Unity, Unreal project. So you can simply open this project and you can do the necessary changes. You can see here SLN, right? So they are already like explaining how to build your own simulator, or you can use the binaries that is already built. Okay, so this is one of the best drone simulator that I have seen. And not only that, there are some other simulator. I actually forgot the name. Just a second. Like AirSim was one. Gazebo is there, but Gazebo is not that much appealing. We can work with drones, but Carla is there. Carla is for self-driving. Carla simulator. Let me check in Google as well. Drone simulators. Maybe you can search for ROS. I think, yeah, mainly the AirSim and Gazebo we can discuss. So you can change the drone model, you can change the data that you require, you can add more sensors. All these things are flexible, and you can train it in a very realistic environment. So that is another advantage. Like if you want to create some machine learning or deep learning based planners, you will get the synthetic data which can be used in the real robot as well. Okay, but in case of Gazebo, it looks artificial, right? So but this can be used in the simulated results can be used and trained for the real world as well. That is the advantage. Okay, yes, so that is AirSim, and there is an AirSim ROS interface as well. If you want to okay, so here you can see here C++ APIs, Python APIs are there. You can see here. Okay, so just run the simulator, then you can write your own C++ code to create the applications. Okay, there is Python APIs. You can communicate to the simulator using Python. You will get the images, all these things that you can use. And if you search for AirSim ROS, there is a wrapper available. Okay, so this is AirSim ROS package. So start the simulator, run the ROS driver, and then you can interact with AirSim using the topics. So you can see here AirSim ROS driver is publishing the GPS point, odometry, sensor data, IMU, all these things. It is subscribing the command velocity, then all the inputs to the drone. Then if you want to take off, reset, land, all these things acting as a services. And there are some parameters, then PD tuning. Yeah, so you can compare with a normal wheeled robots driver. most of the things are the same. Okay, so that is ASIM, one of the best drone simulator. Okay, yes. And coming back to the drone code. Okay, so if you want to build the drone, like as of now we have discussed the drones that is already available, right? We have seen DJI, which is famous. Then we have seen the parrot drones. Then there are drones like um, Dragonfly, I think. Dragonfly drone. Yeah, there is a drone called Dragonfly. It's a very miniature model, very small drone. I think there are very small drones available. I think it was Dragonfly. I actually forgot. Just a second. Yeah, I think we will get it from here. These are the list of drone that is supporting ROS. Yeah, Crazy File was the Crazy Fly. That was the micro drone that I was talking about. And Aztec Pelican was also famous. Yeah. So this drone was also very famous. I'm not sure it is supporting now. Yeah. Yeah, they are not supporting the drone anymore, I guess. Yeah, 2.1 is available. Yeah, so this is a micro drone basically. Okay, and you can use it for SWAM application. Okay, I have seen people in CMU are working on this Crazy File. Okay, and so you may be thinking how to control this robot. Okay, I think there is a ROS wrapper. Okay, ROS wrapper. There is a Python API to control the drones. Okay, you can lift off, land, and you can also control. Okay, so you can see here, if you have a some kind of transceiver, okay, you can simply control it from PC. Okay, so if you check here, maybe we can self check. Yeah, you can see here the Crazy File driver for melodic. It will work for Noitic as well. So if you want to control a Crazy Fly robot, you can easily do using ROS. Okay, so as of now we talked about the existing drone. Okay, there are many drones. We have taken some of the drones, and so what about creating your own drone and interface with ROS? Okay, so that is the next question. So let me close all this stuff. So we can start from that. Okay, we can start from the scratch, creating a drone. Okay, from scratch. Okay, so we can simply go through some DIY guide how to create the drones. So in order to get an idea, okay, and we will see what is the important part of it. Okay, so I'm not sure how many of you build drones from scratch. Anybody build drones before, guys, from scratch? Like after buying these components, anyone assembled and I mean work with the drone? No one, right? Okay. So maybe I can actually start with an experience of drones, like the drone actually created from scratch. Okay, but it didn't work. Okay, so while I was doing my bachelor's, my friends actually planned to create a drone. Okay, And my project was a social robot. Okay, that was my project. So at that time, at that time also I was not a fan of drone, and I know the difficulty as well. Okay, so the what is a real challenge in creating a drone? Okay, not only creating but programming it. Okay, so you all know a drone is actually flying, right? It's not moving in a ground. It's actually need to fly. Okay, and there are in a quadcopter. I mean that's what we are mentioning as drone. There are four motors and the propellers. Okay, so by adjusting the speed of these four motors, the drone need to take off, drone need to land, and drone also need to move. Okay, it has to move in xyz roll pitch you, I mean in a 6 DOF motion, 6 DOF degree of movement. Okay, so I mean how to do that, I mean how to control the speed of this drone. If one motors are like one motor is not working as expected, it will crash. Okay, so it's not an easy task. It's not at all an easy task. Okay, so just imagine you are trying to create a drone from scratch. So what will you do? You will be like buying these components, you will be assembling it. So there are four motors, right? So in order to control these motors, these are like brushless motors because it doesn't require any payload, because only the payload is the propeller. Okay, there is no need of putting additional weight. So the brushless motors are very efficient in this case because there is no friction. It can work perfectly. Okay, so how to control these brushless motors? So there is a motor driver for it. It's specifically called ESC. Okay, ESC. It stands for electronic speed controllers. Okay, so using ESC, you can able to control the speed of these motors. Okay, is that problem solved now? No. So you may be thinking like, what about running all the motors in the same speed? Okay, so if you are running the motors in the same speed, maybe the drone may be lift off, maybe, but it will be like going up, right? So it will not be like standing in one position, it will simply lift off. Okay, so not only like maintaining in same speed, but also we can able to change the speed of each motors, and also it should be balanced. Okay, so the main challenge of building a drone is that controlling the speed of each motors, at the same time the drone should be balanced. So the architecture of the drone, the assembly will be like, the motors of the drones are connected to the ESC. Okay, ESC. Okay, let me check is there is any circuit available, so it will be clear to you. Okay, circuit. Okay, let me take this. This one is not. This one is this one is like ESC. Yeah, but that is shown here. This is for the drone itself, I guess. I mean, yeah, the ESC is doing the same job as H-bridge, but this motor is actually brushless. Okay, H-bridge will be works better for brushed motors, because in wheel robots we are mainly using brush motors, normal motors. Okay, yeah, 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 yeah. Yeah, but the circuitry will be different. The objective is the same. Both the circuit will be controlling the speed, but here you can see the ESC having 3 pins, but in HPage it is having 2 pins. I mean, the brush motors only have two pins, right? So this is a typical circuit of a drone. Like there are 4 motors. Each motors are controlling using ESC, electronic speed control, and this can be controlled using PWM. There is a PWM driver, and here there is an Raspberry Pi. So Raspberry Pi seems like controlling the PWM driver, and there is a camera, additional camera. There is a lipo battery that is powering all the motors, motors, and there is another lipo battery. This is a hobbyist, hobbyist level drone anyway. So there is another lipo battery that is powering the RPi, Raspberry Pi. Okay, but there are some sensors are missing in this. Okay, the sensors are the IMU. Okay, so what happening is that in order to create the balancing algorithm. Okay, balancing algorithm means I already mentioned the motor speed should be adjusted. For example, if the drone is like flying, and if there is any any issue with wind, for example, then if there is no balancing algorithm, the drone will crash. Okay, so even if we if we just move the drone manually, it should balance. Okay, it should balance automatically. So I can show you an extreme scenario. Okay, that is done by ETH Zurich, I guess. Okay, so you will get an understanding what are the things that a drone should do. Okay, yeah, so there are multiple videos. Let me take one. Yeah, so here you can see this is the, I think this is student, I guess. Yeah, so the student is actually giving the ball and these drones are juggling it. Okay, just imagine how we can do this. Okay, and just check the year. It's actually done before 11 years. Okay, and there is one video that is actually inspired my friends. That's why they started creating the quadcopters. Okay, this is actually before 12 years. Okay, and it's called the aggressive quadcopter, done by University of Pennsylvania. Okay, there is a famous professor, and there is a famous lab, GRASP lab, and the professor, I forgot the name. He's an Indian. I can just show you. So University of Pennsylvania, they have a drone lab, and the main professor, let me check. Yeah, Vijay Kumar. Okay, Vijay Kumar, Dr. Vijay Kumar is the main professor. I had an opportunity to see him personally in a conference. Yeah, here is a person. Okay, so they are actually working on this kind of application. It's done before, yeah, in 2010 2009 time. Okay, that's where this project happened, and you can see what are the things this drone is doing. Okay, this drone is like it's flipping. Okay, it's flipping, and it's flying through windows. You can see here. Okay, so while flying, it's actually changing the direction. Okay, it is actually like changing the direction, and there are many videos. If you search for aggressive quadcopter, you can see. Okay, so just imagine the technology that current technology, okay, of drones is much more advanced. Yeah, so these are like perching, like the quadcopter is going and like sticking. Okay, and if you think about like how they can do this, I can show you a hint. I mean, it's not easy, obviously. You can see here there are cameras around the drones. Okay, it's called mainly, I suspect it is Vicon camera. It's a specialized camera in which it can track the motion. Okay, yeah, the Vicon cameras. I can share the. It can be used for tracking. Okay, so these kind of application can be done using that. And if you want to see the acrobatics using drones, that is also here. Just check this. Okay, the drone is actually balancing a pole. Okay, this is very interesting. We are simply like putting a pole on the top of the drone, and it is balancing it. Sometime if we get a pole, we will be trying to balance with our hand, right? But I mean, you know how difficult it is. But that is actually simply doing by this drone. Okay, and not only balancing, it is moving with that, and it can also throw away. I mean, throw that pole. So this is not an easy task. Okay, so in order to do this kind of stuff, we need, I mean, a perfect algorithm, a balancing algorithm on the drone. So that's how the challenge begins. Okay, so there are multiple challenges. One is like the balancing. Yeah, so the balancing is the main challenge. It's not the simple balancing. In order to do this kind of aggressive behavior, we need to have a perfect algorithm in place. Okay, otherwise how to do this? See, this drone is actually moving, and then this drone is catching. Can you imagine? I mean, that's how the algorithm plays here. Okay, so that's how advanced the drone technology now. And there are multiple applications. One of my friend in CMU, they are working on a drone company called Gather AI. So it's for inventory management, so using drones. So an autonomous drone will be like logging all the stuff, and so it will be updating the inventory list or something like that. Okay, so I mean, drones are like playing a lot of roles in companies now, and the technology that developed, I mean, currently the technology is, I mean, it's too complex now. Okay, you can check this. This is like a building a rope bridge with flying machines. Again, I think from yeah, I think from Zurich. Okay, so this is very dangerous, because if the rope actually trapped in the rotors, it will crash. Okay, so yeah, so that's what the challenge is. Okay, so you got an idea, right? It's not about balancing, it's about like creating algorithms to do this kind of application. Okay, okay, so I just want to throw some lights on that. I mean, how difficult the balancing act is in the drones. Okay, so just want to start with our topic. So just go to the dronecode.org. So if you are a beginner, okay, if you are a beginner, and if you want to build drones, there are some existing solutions that is available. Okay, so some balancing controllers, I mean, some controllers available so that you can simply use it and you can tune it. Okay, so one is the px4. Okay, px4, I can show you that. Okay, so this, the px4, I'm not sure you heard about the pixoc. The px4 is actually the software, okay, which can be loaded into the pixoc. That's what my understanding is. So what is pixoc? That is again a question. So if you want to control a drone and if you don't want to program it from scratch, there are some inbuilt boards available so that you can simply connect your drone pins to it, and then you can program it. Okay, so it's like a ready-made board which can be used for the flight control. Okay, so this is this is actually a quite standard standard board. Okay, so you can check here the how the pixoc looks like. Okay, and you can see multiple ports so that we can take it for the drone motors. Okay, and using pixoc you can load pixoc with some firmware. I think that is the px4. Okay, autopilot software. Okay, it is actually the autopilot software, so you can load it in some boards like pixoc. Okay, and then you can do the balancing. I mean, this pixoc and px4 will be using for the balancing. Okay, so that is how most of the people are doing the drone building using an easier way. Okay, this is an easier approach. So you have to purchase the pixoc board, and also you have to set up the px4 firmware, and you can connect the px4 the pixoc board to ROS. Okay, using a project called ROS. Okay, this is just a beginning. Okay, I just mentioned. So the ROS is actually a ROS driver in which we can interface to a pixoc or like any board that is running the px4 based autopilot. Okay, so so you can simply control the drone using it. Okay, so I think we can just pause, and maybe tomorrow we can resume with the simulation, then Mavros, all this stuff. Okay, so I'm just concluding today's class. Like we have talked about, like I started with my experience with drones in CMU. I worked with, and then my project and the DJI drones, all things we have discussed, and how to control the DJI drones. Then after that we talked about like how to create our own drones. Okay, yeah. So I can uh, yeah. These all videos are like available, and there is a YouTube video, like a tech talk, that I can also share, which is really inspiring. Maybe I can simply post ETH Zurich drone TED talk. This one, maybe you may have seen this. It's a very famous yeah, yeah. Yeah, so in that, it is balancing. I mean, they are demonstrating all the capabilities like pole balancing, and also it is balancing a glass of water, which is interesting. Then also like there is control using this stick actually. Using this stick, you can control the drone, and on the top of the drone there is a glass of water. So just think how amazing it is. And the TED talk actually before 9 years. Okay, so these all are things very amazing, and frankly speaking, it's not easy. Okay, it's very complex, and yeah, it's very very complex. And this coordination also, like, see, I mean, a group of drones trying to capture a ball. Okay, so I'm sharing this as well. It's very interesting, those who are not seen this before. And there is one more, this one. This is the next. It's a main tech talk. So this kind of demonstration needs a lot of courage, because this is a main TED event, and if it is fail, it will be a public fail. You can imagine, right? This is a main TED event. Okay, so and he's also like demonstrating a drone with I think three wings or something. The drone will fly. Uh, yeah, I think with this, that was also interesting. Yeah, this is the crazy fly we have discussed, right? So basically, like you can add an LED and use for like some displays. So that's what they are also doing. See, a swarm of crazy fly. Uh, yeah, and you can orchestrate these drones. Okay. Yeah. So yes. So that's it. I think that's it for today. So tomorrow we will be discussing about the Pixhawk, PX4, then gazebo simulation, and let's see the mapping, some packages that we are using for mapping and navigation. Okay. Okay, guys. Thanks for attending. So see you tomorrow. I will let you know if there is any change in the timing. Okay. Okay then. Bye everyone. Good night.